Hey everybody, welcome back to episode 54 of the video series in which we program a video game from scratch from beginning to end in the wonderful C programming language. I know it's been quite a while since the last time I posted. Sorry about that. Been doing a lot of stuff. For example, you might notice I'm in a completely different location. Recently just moved, and that's what's been taking up a lot of my time since I last posted, is moving. And then things started to get kind of busy at work, and then Cyberpunk 2077 came out. So all those things have been really taking away from my video recording time. But today we are back at it finally. So without further ado, let us continue on with what our usual process is, by first reading some comments. I've gained some comments since last time. First commenter says, Ryan, is this full screen really a full screen or a windowed full screen? Do games these days use the same idea to expand the window to fill the screen? Maybe this is a silly question, but I'm new to these practices and Win32 API. By the way, thanks for the series. This is a great question, a fantastic question. He's talking about, so when I start the game, as you can see, it looks full screen. And we've sort of baked this into the code here, where you can change the size at which we draw things, but the aspect ratio is maintained, and it is it's bounded by the size of your monitor. So like you can see here, it goes up to, we can draw at a maximum resolution of 2304 by 1440, because that is the maximum resolution that my monitor, which is 2560 by 1440, but it's the maximum size my monitor can accommodate while maintaining the correct aspect ratio, which our game's resolution is 384 by 240, which I forget what aspect ratio that is. Is it 16 to 10? So yeah, so that my monitor is 16 to 9 aspect ratio, but anyway, I'm really digressing, because it's not what he asked. What he asked was, is this real full screen or windowed full screen? And the answer is simple. It is windowed full screen. Windowed full screen. Let me go to the code where we do this. I assume it's in create main game window, and we are creating a window class, and we register the class, and then we create a window, and then we do all these things where we're getting the native resolution of the monitor, and then we're determining how big can we possibly scale this out to fit your entire monitor without going larger than your monitor, right? And then eventually, towards the very end, I think we, using the set window long pointer A function, I believe we, set window position is the function we use to actually stretch this window. So first we take the border away, we create the window with no borders, like any other Windows 32 application will have borders, and as you can see, the default border style on Windows 10 is almost non-existent. I mean, there's like very, very thin, maybe 1 pixel border on this notepad window. That was not always the case. If you go back in time to earlier versions of Windows, like Windows 7, Windows XP, etc., they had thicker window borders. But since Windows 8, they've been going aesthetically towards a flatter sort of window style. But anyway, you have the option to create your window with any sort of borders you want. You can control the border thickness, the border padding, all this kind of stuff. tons of control over how you create your window. But so I just decided, hey, let's create a window with no borders, and then let's set the coordinates to match the exact dimensions of your monitor. So it stretches over your entire monitor and has no borders. So that's borderless, windowed full screen. So when he says real full screen, and I put real in quotes. Back in the day, well, it's not back in the day because this is still relevant. There's this sort of thing called, it's called exclusive mode, where you basically let the GPU have exclusive access to the GPU. So, sorry, what did I say? When you let the application have exclusive access to the GPU, and that's a real full screen. Games used to work a lot better that way. Back in the Windows, back in the Windows XP and Windows Vista and Windows 7 era, a long time ago, games used to work better typically if they were in exclusive full screen mode. And if you remember back in those days, you could use the Alt Tab keyboard shortcut to switch out of that game and switch back to your desktop. But if you'll remember, it was doing that always used to be a gamble, because most games, or a lot of games, could not gracefully handle that. So they would crash. It would crash your game if you tried to, Alt Tab and switch out of it and stuff like this. The trade-off is that a windowed mode you typically play a lot nicer with your desktop. You could switch tasks. You could go do other things while your game was running in a window on your desktop in the background, instead of taking up your entire monitor. The downside, though, is that windowed mode often did not perform as well as exclusive full screen mode or real full screen mode. That's really kind of a thing. That's all kind of a thing of the past, though, as far as Windows is concerned. Because at some point in time, advances in either Windows or DirectX or video card drivers, or a combination of all three, have reached a point to where windowed mode or windowed full screen mode performs pretty much identically to real full screen mode. And you can verify this yourself. For instance, if you play any of today's video games, like I have, Call of Duty Warzone installed on here, and if you go to the graphics settings in that game, it does still allow you to choose between windowed full screen mode, which is essentially what we're doing here in this game, and real full screen mode. But I don't I can't notice any difference at all between the two. Like, I don't notice any difference in frames per second. I don't notice any difference in visual quality. There's like no difference. So I think that's all I have to say about that. I hope it answers your question. The answer is this is windowed full screen mode. All right, let's move on to the next question. And I have a lot of comments. I made some debugging videos that weren't really part of this series, so I have to skip these comments. Another question about me porting this to Linux and Mac OS. I might, but it's not really a priority right now. It'll probably come much later. It's like once I feel like the game is at a state where my interaction with the operating system is completely done, then we can work on an abstraction layer, I guess, that makes this game more portable. We have 952 subscribers, which is nice. Thank you very much for that. Which I was predicting to hit 1,000 before the end of the year, and I think I would have done that if I hadn't have taken this last month off, but that's okay. All right, next comment says, just finished the video and I'm sure you figured it out. This is a comment on episode 12, by the way. I'm sure that you figured it out, but I found why there were differences in frame rate while using Mem Copy versus Mem Copy S. So I think we did talk about this a while back. Mem Copy S it basically adds an extra safety feature. It checks the size of the buffer before it starts copying into it, and this is to help you, the programmer, avoid buffer overflows, to help you from writing beyond the bounds of your memory allocation. So the good thing about the C programming language is that it really doesn't hide anything, and what's good about that is we know that Mem Copy S is going to be somewhat slower than Mem Copy because Mem Copy S does an extra thing that Mem Copy does not do. And so logic would dictate that Mem Copy S has to be slower because you can't do something for nothing. Like the CPU has clock cycles. It can only execute so many instructions per clock cycle, and that is that. You can't get things for free, and that's what makes programming at a low level that's relatively close to the metal. That's what makes that so appealing to me, because there's nothing hidden from you. There's no, or I should say, there are very few subtleties about it. It's just it's like you do more work. It takes more time on the CPU. Easy as that. Now, contrast that to something like a much higher level language like C# or Java, where you can create a new instance of a class in one line, a very short one line snippet of code, and you think, well, how much time could that possibly take? It's just one thing, right? It's just one, but actually what you don't see and what you don't understand is the constructor of that class can do anything it wants. It can initialize any amount of variables. It can allocate any amount of memory. It could even be making network calls, all unbeknownst to you. You have no idea what's going on, and you think that all you did was create a new instance of a class, but you actually made the computer do a whole lot of work that you were completely unaware of, and that's why your program is slow. Anyway, let's move on. Oh, actually, let's not move on yet. So back to the Mem Copy versus Mem Copy S thing. My point is I actually had to ask this guy, was the difference really noticeable for you? Because as I just said, we know that Mem Copy S has to be a little bit slower than Mem Copy, but I don't anticipate the difference to be noticeable. I think even if we called it 100 times a second, I don't think it would be noticeable in the context of how we're using it in this game. I mean, 60 times a second, 60 frames per second. I just don't foresee it being that big of a deal. But if you're saying it makes a huge difference in FPS, let me know. I don't think it makes that big of a difference. Anyway, I'll move up. I'll move on. This commenter says, great stuff as usual, but I gotta ask, it's been a month since you uploaded. Are you dead? No, I'm not dead. I'm still here. Just been busy, sorry. Next question. I'm not sure if you've answered the question, but in episode 29, why did you choose to write to the registry instead of just saving preferences to a file, like a .config or a .ini? This is also a good question. I know that in every other operating system that is not Windows, everything is config files and ini files. If you go to Linux or Unix, everything, those operating systems don't have a registry like Windows does. Everything is written into config files, which is fine. The main reason that I chose to do registry instead of config file is that the registry is a lot easier to work with if you program Windows. If you program Windows, the Win32 API already has all of the registry functions, all the functions that you need to interact with the registry, read from it, write to it. It's all very simple. In contrast, if I had chosen to save all of the game's settings in a config file, then I would have to have written my own file parser. And you know, we have written a file parser here on this video stream before. Remember when we wrote the function that parses that XML file for the tile map? And remember how not very fun that was. You have to pick up the file, you have to open the file. You know, you might want to read it you might try to read it one line at a time or one character at a time, but you have to manually account for anything weird that might happen. There might be a space after the equal sign. There might be, you know, the user might have put two carriage returns or two new lines after one of the settings, leaving a blank line in the middle of the file. You know, all these sorts of things that you have to account for. So you have to parse it yourself. And that actually would have taken us a lot more time and would have been a lot more error prone and a lot more difficult. So yeah, you know, I'm actually advocating for the Windows registry in this instance. It's a lot easier to use. Next question. Oh, but I'll hold on. Before I go to the next question, I will say that if I ever do port this game to another platform, then we will definitely be revisiting this because, like I said, those other platforms like Linux and Mac OS and Unix and whatever else, they don't have a registry. They only have files. So I'll have to suck it up and bite the bullet and do it then. But anyway, next question. Moving on. Okay, this commenter says, thank you for doing this. You deserve much more views, considering you're explaining stuff. Nice, thank you. By the way, etc., etc. I started following your project in a C++ file. Will this make a difference as the project expands? Probably not. So, I mean, you know, C++ should not theoretically take away any features of C. And what he's talking about is over here on my in my solution, you can see I have a bunch of files. Now, Visual Studio, if you name the file .c, it will treat it as just C, and it will not allow you to use any C++ in these source code files. However, if you rename this file to .cpp, then you can start using C++ in the file. And I basically, the reason I'm constraining myself to C as opposed to allowing myself to use all of the C++ features is because at the end of the day, I don't think that C++ has any features that are particularly useful to me at this time. I mean, I know C++ has a absolute ton of features. I don't really care for any of them though. So I feel like C is all I need. So I feel like opening myself up to C++ at this point would just invite more opportunities for me to make mistakes and for me to write spaghetti code that is harder to debug. And, you know, just I really don't have anything good to say about C++ right now. So, again, my opinions change on a daily basis. So, you know, I may not have such a grim attitude regarding C++. If you ask this again tomorrow, but As of right now, this is why I'm purposefully restricting myself to C. It is very deliberate, and I do not want to use C++. So it's not because I don't know how. I know, inheritance and polymorphism, and I know how classes work and all this kind of stuff, but I don't really need any of that. It's just noise to me. So, but that being said, nothing's stopping you from doing that. If you want, you can use C++. It doesn't matter if you use C++ files without using any actual C++ in them. It doesn't matter. It should be fine. I don't foresee any problems. That being said, if you do run into problems, let me know. I'll try to help you. There might be some issues. If we were to rename all these to .cpp right now. But yeah, I don't think so. I don't think it will be any problem. Okay. This commenter has another question. I also want to ask you another question. So I was following everything, but at some point I got an error when declaring GGameWindow as handle. I changed it to hwind and it worked. Do you know why this would happen? This is another fantastic question. And what he's talking about is, I guess it's in main.h. Yeah. So this is a global variable that I have declared in main.h, and I declared it as an hwind GGameWindow, and it's literally a global handle to the game window. And you use this for all sorts of things. Like you might use this handle in a call to set foreground window, and then you specify GGameWindow, and that tells the Windows API tells it to bring your window to the foreground, right? But what he's talking about is, what if he defined it like this, declared it as a handle instead of an hwind. And as you can see, a handle is really nothing but a memory address. You can tell by the type def. I mean, it's a void star memory address. Nothing to it really. And there's a certain way in which this actually ought to work fine, but he's saying that it doesn't. He says if he changes this to handle, then things stop working. So a handle is just a memory address, and an hwind is just a handle to a window. So it's like all hwinds are handles, but not all handles are hwinds, right? Because you can have handles to all sorts of different things. You can have a handle. You can have a handle to an icon. You can have a handle to a pen. All these little Win32 things. Or actually, I think it's a brush, HBrush. Yeah. So all those are handles to various GDI objects, to various things. They're all handles. The question is, why aren't they interchangeable? I mean, so let me just try to compile this first and see what happens. So one thing I've noticed is that our build time is becoming so atrocious that it feels like we should do something about it. I'm going to have to figure out what step of the build is taking so long. If it's the linker that's having to link all these things together. I mean, and this is a very tiny project, so you wouldn't think it would take too long, but it could also be something else, like the static rules analyzer. That rules engine could be what's taking so long. Anyway, okay, so rebuild succeeded. I didn't get any errors. So let's run it and see what it looks like. that could also be what's making it take so long, is virus scanning. Okay, so it actually still works fine for me, regardless of whether I declare this thing as a handle or an hwind. I was actually hoping that this would cause an error. Okay, that takes an hwind. That takes an hwind. All right, so here is where I'm confused. Is that I don't really understand why it is working perfectly fine for me when I define this thing or declare this thing as a handle as opposed to an hwind. I would have expected to have gotten the same errors as you. But I'll tell you why. I'll tell you, I will tell you, give you some sort of explanation as to why I think that is. Windows data. All right, Windows data types. We're looking for hwind. Okay, so this is the MSDN documentation. An hwind is a handle to a window, and it says this type is declared in windef.h as follows: typedef handle hwind. And that would make sense why that would if this were true, if typedef handle hwind, if that were true, then handle and hwind would be completely 100% equivalent and interchangeable, period. But that's not true. This documentation is wrong, and that is why you got those errors. What this documentation fails to take into account, if you go to, and this is on the same page, over here on the left it says strict type checking. When you define the strict symbol, you enable features that require more care in declaring and using types. This helps you write more portable code. This extra care will also reduce your debugging time. Enabling strict redefines certain data types so that the compiler does not permit assignment from one type to another without an explicit cast. This is especially helpful with Windows code. Errors in passing data types are reported at compile time instead of causing fatal errors at runtime. With Visual C++, strict type checking is defined by default, and then all this stuff. So, and this is literally the exact issue that our commenter describes, is when you are using strict, then your handle and a handle to a GDI object are no longer interchangeable. And the reason for that is because certain API functions require specific GDI objects. And if you pass in the wrong kind of handle to a function, if you pass in a handle to a brush instead of a handle to a DC, or a handle to, something else, a pen or anything else like that, if you pass in the wrong type of GDI object, then the function may crash. It may crash your program. And if everything was just a handle without being a separate, distinct type, there would be no way to tell the difference at compile time. So that's what the strict keyword is all about, and that is what prevents you from using handles and handles to GDI objects interchangeably. Now, the one thing I'm confused about personally is why I don't get any of these errors or warnings on my machine, because I can define or declare this thing as a handle, and I don't get any warnings at all, warnings or errors or anything. And I have strict defined as well. So that's something that I personally don't understand. But anyway, I hope that goes some way to answering your question. Anyway, so yeah, that does it for the comments. And now we're ready to actually do some work on our game. So, I'm going to actually do something here to try to make the build a little bit faster. I'm going to go ahead and take the code analysis. I'm going to turn it off. Code analysis on build. I'm going to turn that off because I feel like that might be slowing down our build times. And I'm also going to it's here in my profile, source, repos. There we go. Okay, so can I exclude this from Windows Defender? Let's see if I can. Windows Security, Virus and Threat Protection, Scan Options, Allowed Threats, Quick Scan, Full Scan. Where are the exclusions? Exclusions. Virus and threat protection settings, real-time sample. Okay, protect. No exclusions. There you go. Add or remove exclusions. Add a folder. I'm going to add source repos game B. Select folder. Yes, I want to allow. Okay, so now the folder that includes all of my stuff for this game, all the source code, is now excluded from virus scanning. So hopefully that should help us improve our build speeds a little bit. And now we can get back to working on this game. Let me switch this back to debug, run it. Since it's been so long since I've messed with this game, I just want to get a good idea for where we are, and also to remind our viewers where we are. So we're at this point where we can start a new game, we can name our character, and we've got music. The controls are pretty good. We can teleport around from one place to another. We've got some dungeon music. We can teleport back out. It's looking pretty good so far. But what we don't have are, we need random, well, what I want to do next is like random monster encounters, because we're going to fight. You remember this is like a Dragon Warrior clone, or, Dragon Warrior, Final Fantasy, JRPG, Pokemon, sort of like that kind of game where you walk around the world and you randomly encounter monsters, you fight them, you gain experience points, all this kind of stuff. In order to do that, though, we're going to need a Windows system. right? We have to have the ability to draw windows on the screen. And windows, drawing windows on the screen is something that if you've ever played this type of game before, you know is pretty much as important as being able to draw text on the screen. Windows are everywhere. Windows are going to give us where we're going to have our monsters for our random monster battles. It's where we're going to draw like our heroes' statistics. You know, his health, his magic points, his experience points, his gold, all this kind of stuff. It's where we're going to display dialogue. It's where we're going to display the inventory. It's where we're going to display like shopkeepers' inventory when you're in a town and you're trying to buy things. All of this stuff goes into Windows. Much like the Windows operating system, where everything is inherently a window, in our game, we are also going to have tons of windows. And I believe now that we're here on main.h, this is probably where I want to start. So we're going to have to create a new function, and it's going to be a create window function. And I anticipate that just like the Windows operating system, the create window function has a lot of options and a lot of parameters. I suspect that our create window function will probably end up having a lot of options and a lot of parameters too, because you may want to create windows that have maybe a window that has a border, maybe a window that has no border. You might want to create a window that has or that's a different color. You know, you may want to create a red window or a green window. You might want to create, maybe we want to have a window that has like a gradient effect, where it's like a dark blue at the bottom and gradually becomes light blue at the top. We might want to create, do like a window with a bitmap background. That would be cool. Yeah, the possibilities are practically endless, but we have to start somewhere, don't we? So I'm going to start with, I'm trying to decide if I want to have this create game window. No, we already have a function called create game window, don't we? Oh, we sure do. We have a create main game window function. I could just call this draw window, I think. All right, we'll go with draw window. And like, do I really want it to return void? I don't know if I want the function to return void, because I might really appreciate having the ability to check the return status of this function, like if for some reason drawing the window failed. But at the same time, I am going to just leave it at void for now. I'll come back to it later. All right, so what are we going to need to draw a window? We're going to need X and Y coordinates, right? We're going to need X and Y coordinate of where to place the window. And we're going to need width and height of how you want to make the window. And I guess we're going to need the color of the window. And I guess that is, oh, and then maybe like a Boolean for, do you want this window to have a border or not? Okay, let's try that. All right, let's do int 16x in int 16y. And then we need a width, height, width, height. We need a color, which I guess is just going to be a pointer to a pixel 32. Background color. Oh, look at me putting spaces in it. Color. And then a Boolean for bordered. Bordered. Yes or no? Okay. I guess that will do. So now I'll go to main.c, go all the way down here, and create this function. There we go. All right, so how are we going to do this? I feel like you know, painting a window, let's see, rectangle. So let's say this is our main game window right here, right? And painting a window, like let's say we wanted to have a dialog box right here. So it's just painting a rectangle inside of a rectangle, right? And then we may want to have another one up here, you know, for this kind of thing. You know, and then we may want to have another window here, and this is where, like in a random monster encounter, this is where the monster is going to sit, right? So you could see why the ability to draw windows and the need to have a really nice, versatile, flexible draw window function is so important to us. So how are we going to do this? I think first thing we need to do, and I'm thinking back to when we did blit 32 BPP bitmap to buffer. I'm thinking back to this function because that's essentially what this function is too, right? We're drawing a rectangular bitmap into a larger rectangular bitmap, which the larger rectangle is simply the background back buffer, right? It's the canvas. But we're still essentially drawing a square on a square, so I think it's pretty much the same thing. And with that being said, I think I'm probably going to copy this because I still need the same calculation, right? I need to do the same calculation. So draw window. And I don't see any need why that needs to be a 32. That can be a 16, just to match everything else. Okay, let's see. Width times height minus width times y plus x. Yeah, that's correct. So this should be pretty easy. So we're going to do a for loop here. And we are going to do, so my feeling is we'll just go row by row. The difference between this function and the blit 32 bits per pixel bitmap function is we essentially had to go pixel by pixel, but we can actually do it faster in DrawWindow if we draw the entire row all at once. So if we can assume that the entire row is all the same color, then we can do it one row at a time, which will be much faster than doing it, you know, 1 pixel at a time or 8 pixels at a time or whatever. If we ever add like bitmap backgrounds, we might have to revise this, I don't know. But anyway, let's just get something down on paper. We'll start with row 0. We'll go as long as row is less than height, and then obviously increment row. I think that's right. All right, and now for every row in the window, we're going to have to calculate memory offset, just like we did in the 32 bits per pixel function. We're going to do memory offset equals starting screen pixel minus what? Width times width times row, right? Starting screen pixel minus game res width times, I can't type, times row. All right, that should be our memory offset. It's where we're going to start drawing, right? And now all we have to do is set the memory. And we can set an entire row of memory all at the same time. Now, I know we've gone over this before, but the reason why we can't use the mem set function, the reason why it's ultimately not going to work for us, is I could, backbuffer memory, background color, and then the size would be something like width times size of pixel 32, which is, this is 4 bytes, right? A pixel 32 is 4 bytes, because each pixel is 4 bytes. But here's why this won't work. I already know ahead of time this won't work, because memset can only set everything to a single byte. So using memset, I could set this to any shade. I could set this to white, which is FF. I could set it to black, all the pixel channels being 0, 0, or any shade of gray in between. But I couldn't set it to any sort of color, because memset will set every color channel of every pixel to the same value, the same byte, the same 8-bit value. And that's the problem with memset. And even though you see that the memset function takes an int as the value, which is 32 bits, it still won't. You could put any sort of, like, let's say this is R, G, B, A, something like this. And this would make some sort of color, and that looks right, but it's actually, what memset will do is it will just take the first byte, like FF, and it will blow that out to every byte in this entire region of memory, and you'll end up with just a pure white, and it will simply truncate all. It'll completely ignore everything after the first byte. So absolutely cannot use it there. But we can use our good old friend STOS-D, which, if you recall, we talked about this before, but I think this is the first place where we're officially going to use it for a good reason other than just demonstration purposes. STOS-D, as you recall, in this whole family of STOS intrinsics, these are CPU intrinsics. If you go and read the Intel CPU manual, it tells you explicitly that this is the fastest way to fill a large block of memory. And when the Intel manual says it, then I believe it. But what we have to do here is we need backbuffer.memory. So this function works just like memset, only you can use it to store a D word, which conveniently is the same thing as a pixel 32, which is essentially an unsigned integer, which is a 32-bit number. So it's like this is good for like a pattern fill, right? It wants a D word. We have a pixel 32, but that can be cast into a D word, right? Because they're essentially the same thing. It's like, 32 bits is 32 bits. Just take the bytes and go. I don't care whether you call it a D word or pixel 32. I'm going to give it color, I think. And let me go ahead and cast that, because I know you're going to need that cast. And then the count will be width. And this time it's just going to be width and not width times size of pixel 32, because now we're writing 4 bytes at a time, so we only have to write width number of bytes, not width times 4, because we're writing 4 bytes at a time, right? Color is undefined because it's actually background color. This probably needs a cast too. What do I need to cast it to? Pointer to a D word. Let's try PD word. Okay. So I think that'll work, actually. I think that is a good start. We'll come back to the bordered part here in a minute. Stos D. I guess that works. So now I need to figure out where would I like to draw a window. And I think I would like to draw a window somewhere in the overworld. Draw. Here is the draw overworld function. We blit our background to buffer. We blit our player, and then we need a window. So let's do draw window. We need an X. What will the X be? I don't know. Let's say 32. What will the Y be? I don't know. Let's say 120. The width will be, I don't know. It could be anything. Let's say 200. The height will be 50. And then the background color will be okay, so this is white. Well, let's just make it black. Alright, so that should be all there is to it. Let's run the game and see what happens. So in the overworld, I should have a little black window down towards the bottom now, I think. Nope, I sure don't. I have this strange blue stripe down here. This may have something to do with it. These warnings. What did I do wrong? Pointer memory. D-word background color width. That's fine. Oops. I forgot to include the memory offset there, which is going to change with each row. So without adding the memory offset, that's why it would only draw one row at the very bottom left-hand side of the screen, because it was drawing at the very beginning of the buffer every time, at every iteration of the for loop. All right. Let's see, we crashed. Why did we crash? Okay. All right. So now that works. So it was a manually inflicted gunshot wound, which is a really common thing to do in C, especially whenever you are in the mindset of constantly trying to economize the size of your data types, like I am. It very often comes to bite you in the butt, because it turns out 16 bits was not large enough to hold this number. Because if you think about it, how many screen pixels do we have? We have 384 by 240. We have this many screen pixels, 92 160, right? That's how many screen pixels we have, and this is too big to fit in a 16-bit integer, which is why I had to promote this to a 32-bit integer. So, as I said, I did that to myself, and it's something, it's like I could have avoided this just by using the, regular data type int. Anyway, let's go on. Let's move on. This part works now. Let's go back to Overworld C. Let's put this in the right place now. I want to put this in. Wait. And again, these can be anything. They don't I guess they do have to be multiples of 4. The width does. All right, and it should be black, so we may still have an issue there. We do. Oh, yeah, it went off the edge of the screen, didn't it? I think. All right, so this brings me to an interesting dilemma, and it's one that I think I'm going to solve with a union. I think that my Pixel 32 data type should probably be a union, which is cool because we've never used unions before in this video series, so that'll give me time to an opportunity to teach something else new. On the downside, we're going to have to refactor, or we're going to have to fix our code a bit here. So here's main.h, and here's our good old-fashioned Pixel 32 data structure. So what I think I'm going to redefine what a Pixel 32 is. I think I'm going to recreate it as a union. So we comment that out there, and I'm going to do typedef union Pixel 32. Now, what a union is, it's pretty simple. A union is basically one location in memory where you can use the same location in memory to store either this data type or that data type. So I'll keep writing and I'll show you what I mean. Maybe it'll become more clear as I write this. So there's going to be, inside of this union, there's going to be a struct called channels, or should it be colors? Okay. And inside of that structure is going to be the same color channels that make up our pixel. Okay. I think that's right. And then it could either be, so this pixel 32, which is now a union, could either be this structure, or it could be a D word, which I'm just going to call bytes. So the structure, the colors structure, and the D word both take up the same amount of memory, right? The exact same amount of memory. They both take up 32 bits. But now we can refer to this location by either this structure, or we can just refer to the whole shebang as this D word. Hopefully that makes sense. I better finish this type def pixel 32. Okay, so I think that will do it. Now the downside is that now we're going to have to go and fix our code everywhere where we used a pixel 32. See, red is not a member of pixel 32. We're just going to have to go fix these now. So instead of textcolor.red, it's going to be textcolor.colors.red. Textcolor.colors.green. Okay, and now we're finally back to our Stos D, which wants a D word. If you want a D word, now we will give you a D word. What do you have to say now? That's right, you have nothing to say now. So now you know what the use of a union is. Now you know why a union can be useful, and it has allowed our Pixel 32 to become more versatile without costing us anything extra, really. Like, it is a little more, it makes our code slightly more complicated, but not much more complicated. And as a bonus, we get a much more versatile data structure that we can now easily, here's our, we don't even need this cast anymore, right? Because we are giving it a D word. We don't need to cast to a D word. This is a D word, right? And the magic all happens because of a union where we have our Pixel 32, and we're now telling the compiler that, hey, this 32 bits of memory, it all depends on how you look at it. You can look at it as a data structure, this data structure right here, or you can look at it as this D word. You can look at it either way you want. It all depends. It's like, that's the magic of the union. So cool. Let's see, overworld.c. So finally, this ought to be a little black. This ought to be painting a black box somewhere on our screen, right? And it is. It's a black screen. Works perfectly fine. So works fine. And now we have our basic draw window function, which is awesome. Next time we will finish out the bordered part of it, like, if bordered, this needs to go in here. But I think we're pretty sure we're well out of time for today, so we'll do that next time. And I guess that is it for today. So, as always, thank you very much for watching. And if you have any comments or questions, please don't hesitate to ask on the videos. You can ask questions about any video at any time. I'll talk about any interesting questions or comments in an upcoming video. If you enjoyed what you saw and you want to continue watching this game being developed, then please hit the subscribe button, hit the like button, tell your friends, all that. And let's see, lastly, don't forget that we have a GitHub repository, companion GitHub repo. It's all open source. You can go and clone the repo, and so that you can follow along at home. That's all I have. So until next time, thank you again, and I'll see you next time. Bye.